Good morning and welcome to our day 2 of physiology. So today as promised we'll be talking about cell. Very basic topic but very enjoyable. And definitely by the end of today's session you'll feel that okay, in such a small cell there are so many things, right? That's what I really felt when I read it for the first time. So let's start with our today's topic. Yeah. Meantime, about the emails, right? Today also we are not taking the emails. We'll take it tomorrow, right? Because there are few matters which are to be discussed, but we'll do it tomorrow. Today's topic is bit lengthy, so I would like to spend full time for this purpose. Right? Tomorrow surely we'll talk about all the emails because there are so many, and so that's why I have written the points. Right? So we'll discuss it tomorrow, definitely. Okay, so let's start with our today's topic, and that is cell. Now, the easiest way to understand our cell, right? Cell, which is like a building block. And whatever we say, that cell consists of this endoplasmic reticulum and smooth and rough, and everything is clear when we read. But seriously, it is exactly like when what we used to say for the pharmacology, right? For the pharmacology, we used to say that pharmacology to badi bewafa, puri raat padi savere safa. Actually, it happens like that. And actually, it happens for almost most of the subjects in medical. When we read, we feel कि हाँ सब याद रह गया. But then when we try to express it, when we try to write it, when we try to recollect it, we figure out that no, many of the things they have been lost. So that's why when I said simply no stress studies, because if you know physiology properly, all the subjects become very easy. So over here, we'll understand the cell as if it is an apartment, right? It is an apartment, and this is a very live apartment, right? Very live apartment in which there are so many nice rooms, then there are few good people, there are few notorious cousins, there are few people who take alcohol, and then there is a good cousin who is getting ice cream for everyone, and then there is a notorious cousin who eats away everyone's food. But when there is fight, to that notorious cousin becomes a gunda, right? And he fights with everyone. So that's like a very live apartment. So that's what we'll really see, right? We'll actually construct our entire apartment. So that's our cell. And then we know that we have got trillions and trillions of cells, right? About yesterday we talked about that there are about 35 to 40 trillion cells. So many cells, yet trillions of cells. And what we are talking about is one such cell, right? And then we'll be going into the depth of it. So gradually we shall expand. And in this, many of the words will be pretty familiar. Now see, think it like that when we have got apartment, right? When we have got apartment, so first what we do, we make a fence, right? So that's our classical apartment, right? Because when we were kid, we used to, everyone means at least not me, even you must be drawing the jhopdi like this only. And then there is a road, right? And then there is a river is always near, right? And then without any dimension, right, there is a boat, right? And in that boat, right, someone, and in the background mountains, they are always like this. And then there is sun, which is like this, you know. That's how we used to draw. No problems, we'll keep it same. But this time, let's add a fence, right? So there is a fence, you know, there is a fence. Mountain, sun. You were also drawing like three crows or cows. A tree also. Yeah, a tree. You must be drawing tree like me only, right? I like this, right? And then this. You know, we used to draw. And if we are more artistic, we used to draw कि यहाँ पे भी थोड़ी Grass. So that's how V-shaped birds are very superb, right? Yeah, these were the birds. Right? Very nice, very nice. Windows, window also. And then in chimney there is some dhua, right? See how creative, how dynamic you are. Same tree, na? Yeah, I knew that. Okay, so cow, I don't know how to draw a cow. And one man. Uh, okay, but this much is sufficient for our today's work, right? So we start with fence. Now fence in case of cell. First I'll just write the names, right? Then we'll be going into the depth. Stick like man. So our fence is like a cell wall. But now you look at the speciality. This fence is sufficient that typical cow won't enter, right? If the fence is proper, so cow won't enter. But those birds, they can enter. It means this fence is not a fully protective system. It would allow someone, it won't allow someone. Such characteristic is called as semi-permeable. Semi-permeable. How it becomes semi-permeable? We'll be going into the depth of all the proteins, about how the channels are formed, how the proteins are formed, how the pores they really make, what is integrated proteins, everything we'll talk about, right? But remember the word this, that it is a semi-permeable cell wall, right? Okay. Now in this cell wall, there would be few doors, true, right? So that is in the membrane, in the cell membrane, there would be few gaps, and they are like doors. They can be like windows. So we know that doors are bigger, windows are smaller. Keep this thing in mind, right? Exactly same thing is going to happen. Let's go inside our apartment, right? Inside the apartment, it is not so that okay, it is only the walls, right? But inside also there are some walls, right? Inside also there are walls, then and then our entire apartment will stay properly. So this inside environment is what is called as the cytoplasm, right? Remember, it is called as the cytoplasm. So how do we draw it? Say if this is a cell, right? So this one is like a cell membrane, right? Or the cell wall, right? In between there will be few gaps, right? How those gaps are there, we'll see. But this internal environment is the cytoplasm. So this cytoplasm is not like bilkul khali like a balloon. No, there are very powerful structures which are lying, right? So that this cell should not collapse, because this cell, one cell connected to second cell to the third cell, fourth, fifth, sixth, and then such trillions of cells, they are making such a powerful body. So that means every cell should be powerful. And that is why this internal environment of the cell, remember, internal environment of the cell, inside the cell, right? Inside the cell, that is solid. So that is where it is a like brick, right? The way bricks they make the entire internal walls, same way internal walls they will be made up with the cytoplasm. And बहुत पढ़ लिया, right? Now we are hungry, right? So let's go to kitchen, right? Let's go to kitchen. And that our kitchen is ER. Now endoplasmic, it is called as endoplasmic reticulum. Reticulum. This endoplasmic reticulum, it is of two types, right? Now see, why to worry, right? We are super rich. So we have got two chefs. We have got two chefs, right? One chef will make good things. Second chef, when the match is going on, so right? So who cares for those healthy food, right? Lao, pizza, and this and that, everything, right? So we have got two types of chef. So one is rough. Now see, rough is good or bad? No, here the rough is good, because see, obviously one who tells कि "अरे चल healthy खाना खाओ," so they are usually rough. And smooth is what? कुछ भी खा लो यार, who cares, right? So they are smooth. So we have got these two. So there would be rough endoplasmic reticulum and there will be smooth endoplasmic reticulum. Now this rough endoplasmic reticulum, he has got someone who will be helping him. So they are the ribosomes, right? They are the ribosomes. Ribosomes, they are actually, you can say that they are like stove or our oven, right? In which the khana will be pakai fine. And it makes what? It makes protein, healthy thing, right? It makes protein, right? Regarding the smooth, big story, right? So we'll take it as it comes. Now, sometimes when the more food is cooked, right, or right now we are not in mood to eat, so what we do? So there is a refrigerator, correct? There is a refrigerator, and that refrigerator where we store that food. So whenever it feels like that we want to eat, garam karke kha lo, right? So literally it is like that. These are the vesicles. They are called as the storage vesicle, right? Storage vesicles. Storage vesicles, they are like refrigerator. And in this refrigerator, and sorry, and in this refrigerator, things are in the form of pre-enzyme. Pre-enzyme. So these are like, have you heard that? Say, all of you must be knowing, right? But these aloo parathas are available, right? That ready made. So just tawe pe garam kiya and then you can have it, right? No need to do any of that sort of food, frozen food, right? It you can't eat it directly, but you have to just process it slightly and then it is ready. So exactly the same way, these pre-enzymes, they are to be activated. Just think it like they are like frozen food. So you just activate it and then oh, yum, right? And you can have it. Sort of instant. But instant is like even Maggi is instant, right? But you have to process it. That classical is that frozen paratha, right? It is in my refrigerator. So whenever you feel like कि चलो खाना है, just तवे पे जरा गरम किया and done, हो गया, right? Just 2 minutes and it's ready. So they are like our refrigerator, right? This refrigerator stores even other things also, right? And then as we'll proceed, we'll introduce those two cousins, right? Acha. Meantime, there is mitochondria. Mitochondria, mitochondria is like our powerhouse. Powerhouse. Now, let's modify it. Right? Powerhouse, we can also say these are like our power banks. These are like our power banks. And these power banks are superb, right? If we need more power banks will be given. If we don't use much, so then less power banks will be available. So these power banks, they are so good, available as per need. And we'll talk about one superb concept of these mitochondria, that why everyone should do exercise. In nutshell, in one sentence, if I say, when you do exercise, that is regular exercise, right? Not 1 day, 2 day, 5 days, 10 days, I'm not talking about regular. Those cells, they feel that yaar, we require more energy, because these mitochondria, what they are producing is ATP, adenosine triphosphate, which is currency of the human body, right? So this ATP, when it is formed, if the cell feels that less energy is getting generated and this person is doing heavy exercise, let's do one thing. Tell mitochondria ke boss multiply ho jao. So they multiply, right? They are like bhoot, right? Bhoot or I don't know what to say, but they ha, right? In that way, right? One, ek mein se do, teen, char, panch, right? They multiply. They become bigger, right? Their size is variable, their numbers are variable, so they multiply, and they are self-replicating. So that means zombie, exactly, zombie, right? They are like zombie, right? So they multiply, and when they multiply, right, they start giving more energy, right? So that is what is the very good thing about regular exercise. And actually you'll feel it that pehle you were running like half a kilometer and now even 5 kilometer is fine, right? What has really happened is this thing. Okay, because muscles won't increase, muscle numbers, they never increase. So that is mitochondria, our powerhouse. And then comes the nucleus, right? And nucleus is our command center, right? In our is our command center, which takes care of everything, right? Sending orders, gotta do this, do that, right? Everything like that. In that command center, there is a nucleolus, right? Nucleolus. So this nucleolus is like deposit safe deposit vault, right? It is like a safe deposit vault in the command center where some blueprints are kept, right? Of some project of or some special things, right? They are kept. So they are taken out when the project is in action. So things which are stored into nucleolus, they are not needed daily, but they are called as when it is needed, when the project is going on, right? And that's it. That's it. We have talked about almost all the components of the cell, right? Now let's go into the depth. We take a new page. So first, let's draw a cell, right? This is a cell. In this cell, there would be nucleus. In that nucleus, there would be nucleolus, right? So we say this is our cell. So this would be cell membrane, correct? Cell membrane, right? In cell membrane, smooth endoplasmic reticulum will come to that. Is not a refrigerator. Those vacuoles, right? Those vacuoles or storage vesicles, they are the refrigerator. Golgi body will come. I have deliberately kept it on one side, right? Golgi body, lysosomes, perioxosomes, right? I have kept them aside because they are the cousins which will be coming up, right? They will come up, Siddhant. Okay, so right, this is cell membrane, right? Then this one is our nucleus. Cell membrane, yes, there is a membrane. Nucleus, yes, it is having the nuclear membrane, right? So we'll change the color and we'll say that this one is the nuclear membrane. Similarly, when we say inside the nucleus, this is nucleolus, right? Nucleolus, correct? Inside. Golgi body is Amazon. You can say that, huh? It is like that. Yeah, nucleolus, but remember one, it has got no limiting walls, right? It has got no limiting walls. Then what kind of safe it is, right? That's the beauty, right? But remember, it has got no limiting walls, right? Obviously, this inside part is called as the cytoplasm, and it is this cytoplasm which is very strong, so that there will be various types of fibers, right? Various type of fibers, and those fibers, many of the fibers you already know. So this cytoplasm, right? The cytoplasm. One thing is when we'll be talking about all the various structures, but in the core, what exactly are they? Very standard, very standard. It is water, ions, protein, carbohydrate, fat. Bus. These are the 5 structures which are making the entire body, right? So one, obviously the water, right? Water. Now most it is like 70 to 80% though, if it will be with water only, and this water will be having so many things. Some things will be properly mixed up, so we'll call them dissolved, right? It would be dissolved, things would be dissolved properly. Some things, they are not properly dissolved, so they'll be suspended, right? When we make nimbu ka sharbat, so then chini, right? Sugar that is properly dissolved. But those Nimbu sharbats, those fine resha, right? They keep on floating. So that is exactly like our cytoplasm, right? Some things are purely mixed, properly dissolved. Some things are suspended, right? Suspended particles, right? So that's how the environment is. So this is about water. What is suspended? What is dissolved? We'll see that, right? This is, it's like bird's eye view, and then step by step we'll keep on going into detail of it. The second, those ions, you know these ions very well, right? You know that because we talked about that outside environment, that is extracellular fluid, that is the ocean. In ocean there is sodium chloride, right? All those. But this is inside environment, so this is basically intracellular fluid, the fluid which is inside the cell. Am I right? So over here, what would be the ions? Which ions you expect? Definitely not sodium, not chloride, not calcium, right? But over here it would be which ions you will find in the intracellular fluid? Potassium, that's right, right? So we'll find potassium. Then another very important would be magnesium, right? And then phosphate, very good, phosphate, right? Phosphate is -3, right? So 1, 2, 3. 1, potassium, magnesium, and the phosphate, right? So these are all present into the ions, and definitely in small quantity, right? Because these ions, they are not like bilkul just I mean just absolutely a pure cutoff, right? No sodium can enter, no calcium, no, it's not like. In small quantity, in small quantity, you will get sodium, right? You will get calcium, right? They will be present. You will get chloride, right? You will get chloride. Yeah, bicarbonate. Yeah, even over here also you will get bicarb. But the only difference is that they are in some small quantity, because that's why that pump is working, correct? That pump is working. The pump which we talked about, sodium, potassium, ATPase pump, an active pump, right? It keeps on moving. So those sodiums, those calciums, right? Those sodiums which have entered, they are pushed out. Those potassium which are outside, they are brought in, right? Yeah, sodium potassium pump. So that's how these ions, they are there. Obviously, when we'll be talking about that pump, we'll be talking about in tremendous detail about that, what exactly that pump works and how it really, yes, ATPase pump, that very right. And that's why it is an active pump, right? It will use energy, it will use currency. Currency is ATP. Now, three things, right? We say protein, carbohydrate, and the lipids, right? So they are there. Sorry. So let's start with the protein. Protein would be there, right? Almost 20% of the structure is made up of protein. So important. Now, no doubt this topic will come up again. But over here, protein, they are of two types. One, which is structural protein, right? Remember, it is like structural protein. And second, which is functional protein. Functional protein. Structural proteins, they are like those bodyguards, right? खड़े रहते हैं यूं करके, right? Functional proteins is your intelligence services, right? So they process, they process, they protect, they protect. Right? So structural proteins, they will be making all those microfilaments, microfilaments. Over here, we'll be telling them fibrils, fibrils, or it is also called as fibrillar protein, right? Fibrillar means they are like fibers, patle patle fibers, and those fibers, they combine together to form a tube. So then we call it tubular protein, right? So fibrillar protein or the tubular protein. So what they really do, see, you must have seen when the construction is going on. So those like lakde ke bamboos, right? Then they are tied and then they start working on it. So same thing, right? This is what is called as the cytoskeleton. cytoskeleton. So it makes the skeleton. Then there are other types of proteins which are utilized for the energy, which are utilized in the enzymes, right? So these are all chemical processes. So that's why these proteins, they will be different, they'll be functional. So we'll call them tubuloglobular, right? They are called as tubuloglobular proteins, and they are like enzymes which will be taking part in so many of the action, and these are moving into the entire cell, because wherever the process which is going on, they will say कि अरे हम है ना, right, let's do, I got the enzyme, चलो मैं काम करके देता हूँ, right? So they are mobile, that is they move in entire cell, right? They move in entire cell, that's their specialty. And then they lead to specific chemical reactions, right? Because there are so many, so right now we are just keeping it like this. So that's how these two are, right? Two functions. The next one, say lipids, right? So this is our what, number 4, right? Number 4, lipids. Lipids. Now these lipids means fat, right? So they will be soluble in fat, obviously, and they would hate water, right? They would hate water. The cell membrane, when we'll see in more detail, the cell membrane, it is made up of bilayers, 2 layers of phospholipids. Phospholipids, right? And there is a bilayer, right? Just within 15-20 minutes, we'll be coming across this topic in tremendous detail. But it is like a cell wall is made, right? This is like a cell wall. These are the cells, right? And then they are having this structure. This is one layer. The second layer goes like this, right? Goes like this, and that's how the entire wall. But it is not only this, like this. There would be few structures which will be going like this through and through, right? There'll be few structures like this. There'll be few structures which will be hanging just like this. There'll be few structures which will be just like this. There'll be few structures which will be just like this, right? And then there would be some other structures which will be sitting in between, right? And then they are affecting the entire cell. So that's how the cell membrane is, right? And every structure, whatever we drew, it has got a name. Right? So this phospholipid bilayer, so basically what it will do is, it will control that what can pass through and what cannot, right? What can pass through and what cannot, because lipids, they are soluble in fat, but they are insoluble in water, right? And that's the game, insoluble in water. So that's the whole game, that who will be allowed to go in and who will not be allowed to go in, right? Another thing is that this fat, right, it is something which is in the form of triglycerides, right? Triglycerides. It is stored in adipocytes. So adipocytes, they are nothing but fat cells. So they are like reserve energy. Now these fat cells, when they get accumulated at various places, right? You must have noticed that classically, that in case of males, it is the tummy which would come out, right? In case of females, usually the fat is accumulated into thighs and hips. Why so, right? The classical thing is because that's like, with the perspective of male and female, depending upon their hormones, these accumulations, they occur, and they are very specific. So it will never be like that you do 1,000 crunches and your tummy fat will go away. No, it would never happen, right? It would never ever happen, because fat goes from the entire body, right? It goes from the entire body. So gradually you'll find that when the fat is getting reduced, even your face would start looking better, right? Because even that from face also the fat is going away, right? Your entire body will start taking the shape. And as I said, that with regular exercise, those mitochondrias, it will start multiplying. So those mitochondria, they will be pumping the energy, right? And when those that energy is utilized, right, it will lead to, say, better efficiency. But so what I was telling about is that these adipocytes, they are like reserve energy. So if someone does heavy exercise, but then he without giving any thought, if he keeps on eating, it's useless. It's useless because then there won't be any energy deficiency. Now, I recently came across one video. एक हफ्ते में 5 किलो वजन कम कीजिए. Now, how much misleading what is, and you know the number of views in 3 days, there were more than 40,000 views. I said, यार wonderful. एक हफ्ते में 5 किलो वजन कम कीजिए. Now it's like a crazy thing. Even if someone goes for absolute fasting, right? Absolute fasting. Came straight from physio lecture training. All right, Akram. So even if someone does fasting, it is useless because the moment he starts eating, immediately the weight would start rising. Initial weight loss is only the water loss. Only the water loss. Person is dehydrated. That's why his water is. That's why his weight is less. Otherwise, just to lose, right? Now you'll be shocked. Many of you must be knowing also. Keto diet is best for weight loss. Well, Shanak, it is. There are many side effects also of keto diet. One of my friends said very precisely the diet is only that diet should be followed which you can follow for years together without any strain. Keto diet, boss, the carb craving is so bad, right? And on top of it, what happens? Is it when the person has thyroid? I lost 8 kilograms in just a week. Really? And in keto, what happens is that because the carb is so less, right? At one point of time, if you want to go for strenuous exercise, it becomes difficult. It becomes really, really difficult. Ah, I agree to that. So for 1 pound, right? See, for 1 pound, that is 400, roughly 400 grams. If you want to lose 400 grams, you would require a calorie deficit. You'll require a calorie deficit of 3,500 calories, right? So you need to calculate this. That if you are a male, now see this calculation, it's totally different from person to person. If you are a male, right, so your calorie requirement would be higher, right? If you are doing some power exercises, say for example weightlifting, right, you are doing punching, right, boxing, such things, right, they will consume more calories. If you are doing some weight exercise, right, say for example leg raise, and that also with power, right, with good weight, what happens that it gives after effect means even if you have stopped the exercise, still next day you will feel that your legs, they are not that smooth, right? They are giving some strain, right? It is the after effect. Now if you do cardio, right, yeah, if you do cardio is like energy is burning. The moment you stop cardio, that's it, khatam. So it is combination of all these things. That is when you create a deficit, right? I mean to say deficit of 3,500 calories, just 400 grams of weight is down. It goes down, just 400 grams, right? Normal requirement of a male is about 2,000 calories. At the most deficiency, how much you'll do? You do of 500 calories, right? After that, so you will feel like "अरे यार चक्कर आ रहा है." You eat one samosa, right? Now that doesn't mean that you guys won't be offering me samosa, right? I'll do extra exercise on that day, but one samosa, it actually gives you about 200 plus calories, right? And if person like me eats 5 samosas, so that comes to about 1,000 calories, right? In marriage, right? In marriage, when we go, we feel so many counters, right? What do we really do? There are so many counters. चल यहाँ से दो दो पापड़ी चाट, राइट, एंड यहाँ पे मिठाई, चलो तीन चार रसगुल्ले, राइट, एंड देन वी सी कि अच्छा नान दिस सब्जी इज ऑल वेरी गुड, दैट इज तो अपना हक बनता है, राइट, तो वी ईट. एंड आइसक्रीम तो कैसे छोड़े ना, दिस इज अनलिमिटेड आइसक्रीम, राइट, एंड एज सच तो वी हैव गिवन द कवर, राइट, तो दैट इज फिक्स्ड, राइट, तो देन लेट्स वसूलीफाई. So we eat एक आइसक्रीम दो आइसक्रीम, you boss you make a total, right? Normally in one marriage, right, people like us, right, that is me and you all included, right, we consume about bindas 5,000 calories. Do hell with the weight loss, right? We actually consume 5,000 calories because that ice cream is so good, right, and it's so tempting. And if you eat just one ice cream, so it is injustice to your brain, injustice to your stomach, right? दो दो आइसक्रीम तो बनते ही हैं. एंड देन इफ दैट समवन हु इज गेटिंग मैरिड, वो आए, अरे साहब आपने आइसक्रीम खाया, हाँ मैं, पर वहाँ पे भीड़ बहुत थी, अरे रुकिए रुकिए, अरे साहब के लिए आइसक्रीम लेके आओ, राइट, एंड वी आर थिंकिंग कि साल तीन आइसक्रीम तो खा के बैठा हूँ, right, but then we can't break his heart, so we have one more ice cream. Definitely the total would cross 5,000. On a dairy milk, it is told that it has 2,000. Is it true value or it's according to its weight? Are it is true value. It is true value. Seriously, we don't care about wedding. Huh? Who cares about wedding, right? Without us, they are not going to wait, right? They, in any case, they'll be getting married. Right? We are interested in the food, and all the counters should be justified. So that's what really happens, right? And then we go for Hajmula. Anyway, this was my personal experience, and we used to do that. And in the hostel, so it was our plan, right? One specific, one special dress, good shirt, good trouser, that was kept. कि जहाँ पे भी शादी हो बुके लेके पहुंच जाओ, हु नोज, राइट, लड़के वाले लड़की वाले, राइट, जाके अरे दोस्त कैसा है हैप्पी, एंड बोथ ऑफ देम विल थिंक कि अच्छा ये इसका या पहचान का है, उसका पहचान का, एंड देन seriously, the things which was shown in Three Idiots, nothing new, right? We have done that so many times, because every time the, see, Sunday evening, right, in Sunday evening, so there is mass is closed, right, because in the morning they have given the food, evening is closed, so शाम के खाने का क्या, right? So it is in marriage season, so this was our plan कि चलो अच्छे अच्छे कपड़े पहन के, and then we used to go. हम साइंस की तरफ से हैं. हाँ, गुलाब जामुन पूरी, यार बस बंद करो ना यार, डोंट राइट सो मेनी थिंग्स. हाँ, अच्छा. So this is what really happens. So every day 500 calorie deficit, right? 500 calorie deficit, then after 1 week you lose 1 pound. And for the deficit of this calorie, right, you have to actually control yourself, right? So that's why you try to fill your stomach with, if you eat lots of salads, so yes, that is good, but one dairy milk, killer, right? It takes away your entire week's exercise, right? That's why in one of the program, who is the biggest loser, that's the American program in which you have to lose the weight, they said, fine, you want to eat this chocolate, go ahead, but this chocolate consists of, say, 600 calories. Now one person burns about 80 calories when he runs 1 kilometer, right? 1 kilometer, so about 80 calories. So all you need to do, you have to run for just 7 kilometers. Let's start. A person would say nahi khana, rehne de, right? That's what it happens. How much calorie needed per day? Well, that's what I said. It varies from person to person. Your weight, your height, your BMR, basal metabolic rate. If your basal metabolic rate is high, right, so it is like you'll be consuming, even when you are not doing exercise, you are consuming more calories, right? If your muscle mass is more, so you'll be consuming more calories. Whatever you eat, you'll be able to digest, you'll be able to consume that many calories at a much faster rate. So it varies from person to person. Anyway, we'll talk about this on Saturday, right, for the fitness part, because this is, many mails have also come about these parts. Coming back to our next point, say lipids, and the finally the carbohydrates, carbs. This is also very important when we talk about, say, keto diet, what you mentioned. Carbs, they are not stored, right? One important thing, that carbs are not stored in the body. In cell, right? If you really check it out, right, it is just hardly 1%, which is in the form of glycogen, right? Just 1%. Someone who is not so in muscles, it might get accumulated by 3%, right? In liver, it goes maximum, right? You must have heard that the liver cirrhosis and fatty liver and all the, in that it goes at the most about 6%, but that also about 6%. Mostly the entire carbohydrate, it is in the form of dissolved glucose. It is in the form of dissolved glucose. So if someone is having diabetes, right? If someone is having diabetes, cut the carbs. Simple. Cut the carbs and see the wonder. Immediately the blood sugar will start falling. Immediately. So cut the carbs. But if you are working heavily, or let's say marathon, right? You are planning to run a marathon. In marathon, to whatever the carbs which you eat, they all will be exhausted, right? Because by the end of 32 to 35 kilometer, they'll be, it's like hitting the wall. Whatever you eat, pizza, pasta, whatever you eat, everything would be exhausted by the time you reach to 32 to 35 kilometer. It is the last 7 kilometers when the body is not having any carbs left out. It has consumed, it has utilized everything, all stores empty. It is at that point when you have to really work very hard, right? So for that, and that's why the carb loading, it is one concept that before about 2 to 3 days prior, you start carb loading. You start drinking so much of water so that you are hydrated properly. Your muscles are soaked with enough fluid, because on that day there would be dehydration, there would be electrolyte loss, there would be carbohydrate loss, and then the body is struggling in last 4 to 5 kilometers, because that's the toughest area. That's the toughest part. In Olympics, you must have seen people getting cramp, right? They have run so beautifully till 30, 35 cramps, and then they exit from the race. Because once those cramps they come, person won't be able to move even 5 meters, right? Even if they try, that cramp gets repeated and then the muscle is jammed, right? Nothing. So that is what is called as the hitting the wall. Hitting the wall. And this is the reason when you cross 35 kilometers, you don't have to run with your power, but you have to run with your brain. You have to run with your brain. You should know your body that at what point cramps come, slow down. Have those electrolytes which are immediately coming into circulation. Don't gulp. Keep that thing into your mouth, because then it will be getting absorbed from the mucous membrane. It will bypass the liver and immediately it will come into circulation. It will come into interstitial fluid and your muscles will start enjoying. So these are some of the secrets, like how you really manage, right? So it will help you a lot. You can take salt, right? If you take salt, salt is absorbed straight away from the tongue. Tongue is richly vascular, right? Immediately it will come into circulation. Within 4 to 5 minutes, right, you will find that your muscles are working fine. You take dates, khajur, right? And then for next 10, 12, 15 minutes, go slow. Let it come into circulation. And when it comes, right, it is long acting. So that's how it works. Carbs will burn if we do run every day. Definitely, surely, right? Surely. So now we move on to our first structure. So in cell, we said that cell is surrounded by, or it is covered by, what is called as the cell membrane, right? Cell membrane. So our cell membrane in our apartment, it is like a wall, right? It is like a wall. Now this wall, Even in our apartment, it is not so that only there are outer walls, right? There are inner walls also, right? There are inner walls also. Say for example, say in living room there is a wall, right? In bedroom there is a wall, right? In kitchen there is another wall, right? There are walls, some are thick, some are thin, but there are. Same way there would be the wall, there would be the membrane that would be surrounding the cell, so we'll call it cell membrane, right? There would be wall which will be surrounding, we just saw, nuclear membrane. You got the idea? Nuclear membrane, right? There is a nucleus, so there is a nuclear membrane. There is no membrane for the nucleolus, which was inside, right? Because nucleolus is as such, it is just a collection of RNA, riboxynucleic acid. So it is RNA and few proteins, right? We'll talk about it. Then our kitchen, endoplasmic reticulum, right? It has got the wall, right? Our powerhouse, mitochondria, right? Our powerhouse has got the wall. All these walls are special. Obviously, for a kitchen, right, we'll be making the wall which are like fireproof, right? Our outer walls, they are like कि बाहर बारिश हो तो पानी अंदर नहीं आना चाहिए, so they should be waterproof, right? Same principles, right? Same principles. God has created this entire thing so beautifully. And now we introduce two more structures. One, Golgi apparatus, right? Golgi apparatus. This and our first cousin, lysosome. So even they are having walls, right? Who are they? Just hold on for a few minutes. Moving on to this membrane. This membrane is very specific. We take it on a new page, right? Cell membrane. So when I say cell membrane, it is not only the membrane which is surrounding the cell, but all the membranes which we talked about. This is also called as the plasma membrane, right? Plasma membrane. But cell membrane or the plasma membrane which is surrounding, it is very specific. And as we said, it is a bilayer. Bi means two. It is a bilayer. Bilayer made up of phospholipid. That means there is a phosphate group and there is a lipid layer. So it is a combination of phosphate and lipid, right? So we'll draw it like over here, this. We'll draw it like this, draw it like this. So this is P is phosphate, right? P is phosphate. But because it is double layer, so next second layer it is ulta, like this, right? So we don't have to cram. If we say this is phosphate, so then obviously this portion, right? This portion is what? It has to be lipid, correct? So this is lipid. Lipid means what? Lipid means fat. Now you take water, put some oil into it, right? You'll say it won't mix because fat never loves water, right? Fat never loves water. So this fat is in fact afraid of water. When someone is afraid, we say it phobia, right? Or the person is phobic. That means fear. It has got fear of water. So when it is fear, we are scientific people. So we won't say water phobic, right? We'll say hydrophobic, right? So this is hydrophobic. It means this particular layer, this in-between layer, it is loving fat, right? It loves fat because it is made up of fat. So, right, it would love fat, but it would hate water. Very important principle, because it is this layer which is not allowing water to come inside, right? So this layer is impermeable. Impermeable means water cannot enter or water cannot pass. So it is impermeable to water, right? But well, water should come and go. Well, there are methods. But basically it is impermeable to water. So if the water is not allowed, to then anything which is mixed in water is also not allowed, right? So it won't allow water And in water, glucose mix very well, right? So it will say no to glucose also. It will say no to urea also. None of these things are allowed. Water and anything which is properly mixed into water, they are not allowed, right? So that is what it is called as the hydrophobic. Now, this is outer one. So let's consider that this is our entire cell and this is inside of the cell. This side is inside. So can I say that this is intracellular fluid? This is ICF, right? It is inside, and this outside one would be the extracellular fluid. So in other words, what I'm drawing is that this is the cell and this is like our membrane, right? A bilayer membrane. So this is ECF and this is ICF. And in between there is this bilayer of phospholipid, correct? Phospholipid. And this, there is water outside, there is water inside, and water is very much interested in going outer and inner. No, but it is not allowed by that layer which is in between, hydrophobic. And yes, we can also call it lipophilic, right? Lipophilic means it loves fat, correct? So same way, the ulta of it is the outer area, those phosphates, right? Those phosphates, they love water, right? So we'll call them hydrophilic, right? Hydrophilic. So phosphate over here and the phosphate over here. So that is also hydrophilic, right? It loves water. So far everything is easy, right? So we have got the phospholipid which is making this particular layer. Phospholipid is one, but then there are two other types, right? Phospholipid is what we saw in most of the cell membranes. It is this phospholipid, it is there, that is one. But there is one more. It is called as sphingolipids, right? It is called as sphingolipids. So these sphingolipids, they are a bit special. So you will find sphingolipids into nerve cells, right? Sphingolipids. And then there is one which is called as the cholesterol. This cholesterol is very vital, extremely vital, because what it is doing, it is like a very fine control, and it handles what's called as the permeability, right? It handles permeability. Permeability means what can go and what can come out, right? So, and permeability to what? Obviously permeability to whom? We were saying no. We were saying no to whom? To water, right? So it controls or it handles permeability to water and everything which was getting dissolved. So water soluble items, right? We could have written water soluble components, but items, right? So technically speaking, it is called as cholesterol handles. This is a very nice word, fluidity. This thing is called as fluidity, right? So our wall is ready, but this wall is not that simple, right? Just two layers. There are some things which are inside, and these inside things, they are very, very good, very interesting. So let's draw like this, right? This is our wall getting ready, and that's the wall, that's a wall which is ready. But then there are few proteins, right? So that's how the entire wall is. And now comes some specific proteins. Some proteins are such that you just can't take them out. They are part and parcel of this cell membrane. So they are called as the integral protein, someone which is passing through and through. So we'll draw it like this, which is passing through and through. If you want to remove this protein, you have to break the cell wall, but they won't go. Such proteins, right? Such proteins, they are called as integral proteins, right? Well, there are some other type of proteins also. These are the proteins which are just doing hi hello, right? Just this much or just this much, right? They are attached on either of the side, right? Intrinsic, yes, we'll come to that, right? Definitely will come to that. So integral protein is that which is just part of it. And then these are called as the peripheral protein. Peripheral, right? Peripheral proteins. So we know that just from its arrangement, one passing through and through and one which is on one side. So peripheral protein, one we can remember that it is on one side only. It is on one side only, right? Another speciality of it is that these proteins, because they are on one side, so they have got nothing to do what is on the opposite side, right? They don't have to do anything. So they will play their role only in their own environment, and that's why this is usually they will be acting as, they act as an enzyme, right? So that they'll say that let me make the process faster, let me make the process better, right? So this is where it will be like communicating with the internal environment. Our integral proteins, they are just superb, right? Because they pass through and through and through they have passed, right? Now we just cannot remove it. So who are they? The first one, right? This protein. Say for example, we have made the walls, but have you noticed one thing? That in some cases, in some apartments, right, there is a kitchen. There is a kitchen, right? And in between there is a wall, right? In between there is a wall, and then the dining table is there. So then there is a service window. Nowadays, so this is not seen well, but there is a service window. So garam rotis which are getting made, right? They are kept over here, and यहाँ से लेके you just have it. Correct? That is like a service window, that choti si window. So things go easily, right? Exactly, Shonak, you are right. They are like channels, right? They are like channels. They are called as channels, right? Also called as the pores, right? You can call it channel or pores. So when the channel is there, so ions, right? They can diffuse from extracellular environment to intracellular environment. Simple, right? Because that is a service window, right? Go and come, right? It keeps on happening, right? So this is one type, one change within our walls. The second one, this is like our carrier proteins. They act as a carrier. Carrier means what? Carrier means they'll say that give the parcel to me in hotels, exactly, in hotels, right? That service window sort of thing. Yeah. Now he is our waiter. He is our waiter. He says किसी kitchen में जाना allowed नहीं है, right? But आप बोलो क्या चाहिए, right? I'll get it for you. Carrier proteins, they are like that, right? They work even against electrochemical gradient. Electrochemical gradient is what? Electrochemical gradient is that on one side, if there is lots of potassium, on opposite side there is less potassium, but still you want to move this inside potassium out, right? Over there is so much of potassium, and over here it is less. Obviously from higher concentration to lower concentration, it will try to go. You want, no, I don't want this. I want that against this throw it out. This is where energy is needed because you have to work against, and that's why they are active. Very right, they are active. And when they are active, that means you need money. And in body, money is what? ATP, adenosine triphosphate. ATP cannot be used directly. You require an enzyme, that is ATPase, right? And the best of the example is, yes, you know that it is sodium, potassium, ATPase, active pump, right? Active pump, right? So that's like our system against the ADP, right? ATP, right? ATP. ADP is to be converted, right? ADP, adenosine diphosphate, right? It is AMP, that is monophosphate, in which there is one phosphate group, adenosine diphosphate, in which two, but we use the currency adenosine triphosphate, in which there are three phosphates, right? So it is ATP. Right, so this is the second part, and the third part is my favorite. The third part is the beauty of our system, and that is the receptors. We'll be taking not 1 day but at least 3 days for receptors only. If you know receptors properly, trust me, pharmacology is easy, medicine is easy. Actually, things will start coming in your mind. Yes, this drug will affect eyes, this drug will affect lungs, this drug won't affect the heart, right? You'll be able to decipher, you won't have to cram. So receptor is that. And what receptor is, it is like an electronic system, right? Now, I made one electric bell, right? Way back when I was in seventh standard. I told my father that just give me some paisa, thode paise, right? And it's like I connected that a small switch to the door. So when the door gets closed, that is when you do the handle, right? And jab tala lagao aap, right? So हाँ. So when you do that, so that LED, right, that bulb, I put those big bulbs. So it will turn to red. That means out, right? And when you open the tala, it will shift back to in. What really happened is, right, there was some mistake in the wiring, and the current came into that handle. So so there was no current, right? There was no current when the door was open. My father said, "ठीक है, ताला लगा दो." Arey, then the moment I closed, right? Yes, that light turned red, but matlab, there was such a huge shock, right? Yes, there was huge shock, right? ऐसी ऐसा चिल्लाया. But then I noticed कि अच्छा कहाँ पे गलती हुई. So it happens, right? In I think in sixth or in seventh standard only, right? I asked my dad that how 440 नहीं, it was 220 volts. 440 का तो नहीं लगा था, पर you said about 440 ना. Actually, I did that, right? Actually, I did that, and it was that I asked my father कि ये how this bulb, right? Our bulb glows, right? So he said that there is a tungsten filament, and inside there is nitrogen. Nitrogen, in presence of nitrogen, this tungsten filament won't burn, right? Didn't your daddy scold? No, right? I opened, means at that time it was a black and white TV, brand new TV. I thought कि इसके अंदर से आवाज कैसे आती है, picture कैसे आता है. When my daddy went to the bank, right? He was in bank. I opened the TV. I took the circuits out, right? I was watching कि अरे यार क्या wonderful चीज है, right? At that time I was in ninth standard, eighth standard or ninth standard, right? Fine, everything fine. वापस रखा, TV चालू किया, नहीं हुआ ठीक. Right? My father came, right? In the evening, I said, nahi chal raha. He said, what have you done? I said, aisa kiya. He said, no problem, chalo. He took me to that TV repairing institute, right? TV repairing institute. I studied the entire TV, how to repair it. And yes, in second MBBS, right? Because there was not enough of the money. So I used to go after clinics. I used to go on my cycle. टीवी रिपेयर करके रात को 12 बजे तक टीवी रिपेयर करते थे. And I used to earn 50 rupees a day, right? So that thing helped. So that was my first love for electronics. But this is very interesting. When I said, "ठीक है, see, this is how the tungsten filament, it really gives so much of light." I was very happy. Yes, daddy ने नई चीज सिखाई. My mom and dad, they went for the movie, and I told my sister, कि देख, I show you something. And you know that in parda there are those springs, right? Those metal springs. So in that was 440 volt, right? 440 volt, right? I took that thing out, right? That refrigerator plug out, one spring here, and I told my sister कि देख अब मेरे में से कितनी light निकलेगी, because my logic was कि if the tungsten filament can illuminate, so can I, right? Because I was here. So and I said switch on कर. She was smart enough. She said कि नहीं नहीं. I said don't worry, right? हिम्मत चाहिए. I hold both the springs और पाँव से I switched on this switch, and boom, the main transformer of the society, it got blew up, right? Entire society was electricity failure. And then my all hairs were burnt, and then it was literally like that cartoon film, right? I was unconscious, fell some 10-15 feet behind, right? And my sister is shouting. My mom and dad, they were watching the movie, and then on the display it came, "Mr. Jani, right, you are requested to reach to the home instantly," because at that time only the slides were there, right? You remember there were slides, right? There was no digital thing. And they came, right? And then, well, everything was fine. I survived. My first question to my sister was, मेरे में से लाइट निकली थी? And still my father said कि कभी डांटा नहीं, right? कभी कभी नहीं डांटा. He said कि see, this is yeah, I must have been illuminated, but I was unable to see that. Even in one of the thing, because say if I ask you a question, one pencil, right? What is the distance that pencil writes, right? You know that? Now, say it was a freshly painted, beautifully painted, our house was painted, right? It was some Diwali time. रात को ये सोचा कि यार ये कितना लिखती है. फाइन, राइट? दिस इज द एंटायर हाउस. एक दीवार से शुरू किया, राइट? जहाँ पे भी रुके एंड पेंसिल से ऐसे लाइन खींचना शुरू किया, जहाँ पे भी वो खत्म हुई वापस पेंसिल को छीला एंड वापस शुरू शुरू, राइट? ऑल द वे, राइट? फिनिश्ड इट, right? And then with a scale I started measuring 6 inch, 12 inch, 18 inch, 24 inch, right? That way. And my mom woke up, right? And फिर तो क्या मार पड़े, right? But well, I calculated. My father said, अच्छा अच्छा अब कर ही दिया है तो finish it, right? Give me the total length. That एक pencil कितना लिखती है? One pencil writes about 431 meters, right? That was the thing. But वो बात अलग है कि then I had to really clean those walls, and they were never cleaned properly because there were few dag, but my father said that's okay, no problems, right? It is like you did something, you calculated something very properly. Arre, don't ask, right? Don't ask about the himmat. We have done such khel that someday when we'll meet personally, I'll tell you. हाँ दाग अच्छा है, seriously. Means I was very notorious kid. Now I am very sharif, right? At least that's what I think so. Okay, so receptors, they are what? Receptors are super cool, right? Receptors, we can't do. Arre karo, right? Don't take my name, right? But karo. That's the age to do it. That's he was like my friend. Very true. We used to race, right? I used to drive Bullet and he used to drive Kawasaki. Because when he passed away, I cried like a kid. Yeah, it was so difficult. Okay, so coming back to this receptor, this is what is called as the ligand. Ligand. Ligand means that substance, when it touches the receptor, receptor will be excited, right? And this receptor will send the signals inside into the internal environment, into the intracellular fluid zone, that okay, something has happened and you need to make some changes inside. Now there are various types of receptor. That's why I said, alright, do it, right? Do it. So those receptors, right? Those receptors, when the ligand is connected, something happens inside in the internal environment, and that internal environment will lead to synthesis of some proteins, right? Synthesis of some proteins, and and that is what is called as the second messenger. Second messenger. So the message has come from outside, right? And then it would say, "Acha, okay," right? As if this is some gang which is going on, right? It will say, "Acha, information andar pahuncha do," right? So in the intracellular component, information goes, message goes to this second messenger, and this second messenger will tell that okay, finish, right? Supari. So that's how these receptors work, in and out communication. So receptors are those where cells actually communicate with the external world, right? So that's what is called as the receptor, and receptor is also a type of protein which will be passing through and through, right? Yes. So there are all types of ligand gated ion channels, then there are voltage gated channels, right? All various types of channels, that the moment a specific voltage is reached, channels open and dug 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 dug, right? It goes inside, right? That is why the action potentials and everything would start. So when we'll be learning about action potential, we'll actually talk about every gate, right? Why some gates open, why some gates close, why when one gate opens, second gate closes, right? So there are various types of mechanisms. So all of them will be discussing. So that's why receptors a beauty topic, right? So that's what we'll be learning. Now these integrated proteins, right? They are not very simple protein. They are not very simple protein or very sharif protein like me, right? These proteins, this is a cell wall, right? This is a cell wall, right? Crudely, it is cell membrane. I'm just writing cell wall. And then this is our receptor, right? Ligand is external stimulus. You can take like external stimulus. बाहर से किसी ने information दी, right? This is the external world. So anything from outside, it touches, it attaches, right? If there is any change in the temperature, if there is any change in the voltage, anything, these are all external stimulus. That's what we said, voltage activated, when the voltage changes, temperature activated, right? So it would immediately send some signal to inside. कह रहा बाहर ऐसा हुआ, so we need to make a change, right? That's how it works. Now on top of it, there is like a crown over here. There is something attached on the head. This is external environment, right? We are talking about external. So this external environment, it is where there is a glycoprotein, right? It is like a crown. It is like a crown, you can say. So it is like a crown. And this thing is called as the glycoprotein, right? Glycoprotein. So this glyco is outside and this protein is what is connected, right? This glycoprotein, it is making so many things, so many changes in the cell. Collectively, this whole unit is called as the glycocalyx. Glycocalyx. Now, what is the function of this glycocalyx? Right. So now we are talking about function of glycocalyx. 1. This glycocalyx is keeping the surface negative, right? Because it is negatively charged. It is negatively charged. So cell surface, because that's what we said. This glycocalyx is on the top of on the head of our cell wall, right? So obviously it is outside. So cell surface, it is negatively charged, right? Is it good or bad? Well, whether it is good or bad, we'll understand when we'll be learning about the action potential, right? When the voltage goes negative and then it shoots plus, and then there are some changes, right? All those graphs, you'll understand that it is this step which is very important. It has to be negatively charged. It has to be. Then and then the entire process works so fine. Second, because of this glycocalyx, right? These glycocalyx, they also attach with each other. So attached with each cells are attached with each other. So they are holding hands with each other, right? So this is one. Third, insulin, which is vital. So this glycocalyx, right, it acts as a receptor. Acha, by the way, whenever we'll write R and the circle, so it is, we'll call it receptor, because this receptor word now will keep on coming again and again. It will keep on coming, right? So we'll call, now onwards we'll write R and circular to where it is receptor, right? When it is voltage gated, so we'll write initially voltage gated, then we'll start creating the symbols. Because when we'll be learning pharmacology, all these words will be very important, right? Instantly we'll be able to figure out that whether this drug will go inside or not, what it will really do. So this receptor is for binding insulin, right? So it is this glycocalyx will be playing a major role, very important role, when we'll be talking about insulin, how insulin binds, and then it tells that what is to be done for the glucose, blood glucose, right? And it has got some role in immunity, in immune system, right? In immune system, how it takes care of of some part into the immune system. So again, when we'll be discussing immunity, this thing will come into picture. But the most important of all, obviously, it is the negatively charged cell surface. Rest are specific for cells. It's not for every cell, right? Not every cell, yeah, obviously attached, so that's fine. But not every cell will be handling the insulin, or not every cell will be taking part into the immune system. This is just in general, right? Now let's go inside the cell. All right. And we have studied enough. So let's go to kitchen. Inside the cell. And inside the cell, this is our all-time favorite, our kitchen, right? Our kitchen. And this is called as the endoplasmic reticulum. Endoplasmic reticulum, right? Now this endoplasmic reticulum is literally thrown into layers, right? All those layers, right? It's like that, right? All those layers, right? And wavy layers, right? It's thrown into folds. There are multiple folds, and in these folds there would be all like these shapes, right? These are called as the cistern, right? cisterne, cistern. So they are like cistern, where this is thrown into folds, right? In between these layers, right? In between, there is what is called as the matrix. Matrix, you can consider it is like a filler fluid, right? You can say that this is like endoplasmic matrix, because there cannot be any air, right? So it has to be filled with some fluid like thing, so it is filled with it. Now as the whole structure is thrown into folds, it increases surface area. And that's the beauty of our body, increases surface area. Even in our brain, right? Nothing is absolutely rounded. The brain, if you really see, so it is thrown into folds like this, right? Sulci and gyri, right? It is thrown into folds. So because it increases surface area. Same thing over here. It is thrown into folds, so it increases surface area, because you require more area so that more processing can be done, because everything is like one particular seat which is working. So now comes that endoplasmic reticulum is a structure which is thrown into folds. But there are two types. One, what is called as the rough ER, rough endoplasmic reticulum. Yes, that apna healthy, right? Healthy one. Why we say it rough? Because, well, it has got R for ribosome, ribosome, right? R for ribosome. This ribosome is good, right? Basically, what it will do, protein synthesis, right? Protein is good, protein synthesis. And this rough endoplasmic reticulum, right? See, this is like endoplasmic reticulum. But when there are ribosomes, so there are dot 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 dot, and that's why we feel like that this is rough, right? If there are no ribosomes, so it is called as the smooth endoplasmic reticulum. Smooth ER. Smooth ER means no ribosomes, no ribo, right? There are no ribosomes. So what they do, they'll make all pakoras, right? Synthesis of, right? Synthesis of lipids, right? All must the fatty things, right? So that's what they do. Both are needed. You know? Okay, so that's how that smooth endoplasmic reticulum. Now this matter is not ending up over here, right? Because when the pakoras are made, right? So when you eat pakoda, so you would definitely feel like ke chalo, let's send one plate to sir also, right? So you will send one plate to me, right? See how smartly I'm planning. I planned for samosa, and yes, you know the list, right? So add these pakodas also. So from the smooth endoplasmic reticulum, right, from one plate, right, one plate, it goes to one area which is very near to smooth endoplasmic reticulum, and that is called as the Golgi apparatus. Golgi apparatus, right? So this is very similar to smooth endoplasmic reticulum, but only thing is we will send one to Biden also. Okay, but first me, right? So here, what Golgi apparatus is doing, just remember, right? It is like transported from smooth endoplasmic reticulum, right? That pakoda plate which you have sent, you are sending from your side to my side, right? And then I'll process it, right? This process is going into Golgi apparatus, right? I used to say to my mom कि यार ये पकोड़े बिगड़ जाएंगे, right? So इसलिए मैंने safely पेट में रख दिया, so that खराब ना हो जाए, right? Such good intention. So this is process. It gets processed. Your pakoras, they will be processed over here. अरे नहीं यार, that's fine. Zomato में क्या मजा, right? When we meet personally, at that point you remember, ठीक है? So here it is. When it is processed, now I can't eat because see you guys there are so many people, right? You guys are in number. So if everyone starts sending one plate, so now that would be too much. So then what I have to do? I have to distribute it, right? जितना खा सकूँ खाऊंगा. But then I have to call my cousin. His name is lysosome, right? Lysosome, right? We'll meet soon. We'll meet soon. So then I'll call my cousin. यार, there are so many pakoras. So do one thing, right? लेके जाओ, right? And give it to other friends also. So this lysosome, right, will take this, will store it, right, so that खराब ना हो जाए, right, into the vesicle, right, into the vesicle. Vesicle means dabba, store karke rakha, right? So vesicle means it is like sack like, right? Dabba, right? It is put. And then these vesicles, right, they will start moving. These lysosomes, they will start moving. They are mobile. They are mobile in cell, right? So they will move, right? So they will start moving. And what will they do? They will travel to various places, right? They will travel to various places, these vesicles, and they will lead to one of the very important thing. It is what is called as the intracellular digestion. Intracellular digestion. Now, what exactly this intracellular digestion is? Sorry. Now, see, this lysosome will produce one hormone, not hormone, enzyme, right? And that enzyme is called as the hydrolase, right? Hydrolase. Ending with ase, so that means this is one enzyme, right? This is a hydrolytic enzyme. Hydrolytic. Lytic means to break. So it will break something. It is going to break something. What it will break? Well, now see. Hydrolytic enzyme is into the vesicle, into the lysosome, right? Lysosome has packed it, right? It has lysosome has prepared, packed it into the vesicles and chodo. Packed into vesicle, jane do, right? So they are now all floating into the cell. They will do one. Any structure which is damaged, right? Any structure which is damaged, digest, right? Cleansing process, digest damaged structure. Then anyone unwanted, bacteria, kill them, digest them, right? So that is what is called as the intracellular digestion. Also, the specific food, right? That is also broken down. It is broken down. Now what type of food? How exactly what are we talking about? We said that it is by the process of hydrolase. Hydrolase, correct? So it is hydrolytic enzyme. When will it is hydrolytic enzyme? So it does this. Hydro means water, right? So easy to remember. Let's break the water into two parts. So H plus and OH minus. Am I right? H is hydrogen, right? It is called as hydrogen, right? And OH minus is called as hydroxyl. Hydroxyl. When these two, they are attached to a compound, right? They are attached. Now it could be, if it is protein, so then protein is broken down, or we would say protein is hydrolyzed into amino acids, right? Protein is hydrolyzed, right? This is what is called as the process of hydrolysis, right? So this is called as process of hydrolysis. So it is hydrolyzed into amino acids. When it is, say, glycogen, right? Glycogen. So then that glycogen is hydrolyzed into glucose. Glucose. When it comes to lipids, right? So then it is broken down. It is broken down into two things: fatty acids plus glycerol. And one thing which you must have noticed, that this amino acid, right, or amino acids or glucose or fatty acids or this glycerol, they all can be utilized directly. They can be utilized directly, right? So that's how it really goes, right? So that's how they go. Now, in case of, say, lysosome, when this is prepared, right? In case of lysosome, inside there is hydrolytic, right? Hydrolytic, right? So that's why its wall, right? This wall is protective. Wall is protective. It won't allow unnecessary, this hydrolytic enzyme to come out, because otherwise so they'll start digesting even good cells, good part of the cells. So that's how it is taken care of. So this is lysosome, but there is one more, right? The way lysosome is there, there is one more, and it is called as the peroxisome. It is called as peroxisome. Same, right? If the lysosome was part, it was coming up from the Golgi apparatus, same thing peroxisome also. But this peroxisome can be self-replicate. It can self-replicate also. It can self-replicate. It has got the capability of self-replicate. That's the one change. And second, lysosome was having hydrolase, right? It was leading to hydrolysis. This is leading to oxidase. Don't forget this thing. This is our Gunda cousin, right? It is our Gunda cousin, right? Literally, he'll do all maramari, right? This is cousin of lysosome. See, the surname is same, lysosome and the peroxisome, right? Same surname. So this one, oxidase, right? What it will do, oxygen, hydrogen, right? Combine and it will create H2O2. This is the process of oxidase, and this is what it is called as the hydrogen peroxidase. Hydrogen peroxide, right? Hydrogen peroxide. This hydrogen peroxide, it is a catalase. Catalase means it cuts, right? It is a catalase. It cuts. It destroys, right? It removes poison. Poison, every day we are not taking this poison, but yes, it takes care of all those which are poisonous for the body. And the most important thing, that when the alcohol has been consumed, it is necessary to break or the detoxify this alcohol into acetaldehyde, right? It is acetaldehyde, aldehyde, right? Because this acetaldehyde is sober, right? Yeah, it is applied on wound. That's right, right? Because it is a very powerful cleanser. So this is the detoxification. This is the detoxification. And this thing is thanks to our peroxisome, right? Because almost whatever the amount of alcohol it is consumed, 50% of the alcohol is detoxified into acetaldehyde by this lysosome. So though he is Gunda, but he is good, right? He is good. Now, say this peroxisome, lysosome, Golgi apparatus, right? All of them, they say कि हम तो constantly काम करते रहते हैं. They keep on working, right? Say endoplasmic, smooth endoplasmic reticulum, right? There's Golgi apparatus, right? They keep on working. They keep on making those enzymes. But body would say कि you guys make this thing so much, I can't use it so fast, right? So that's why all these secretions, they are stored into vesicles. What we were talking about in lysosome, right? Lysosome, but even this Golgi, SCR, all of them, right? They are called as the storage vesicles. Storage vesicles, right? They are also called as storage granules. They are also called as secretory vesicles. But the whole idea is they store and use when needed. Use when needed. And that's what these guys they do, right? So whether it is protein or lipid, right, they just store it in, right? Over there, they are protein or lipids, they are just stored in it. Say for example, in case of pancreas, right? In pancreas, so these lysosomes or these vesicles, storage vesicles, right? They will store proenzyme. Now this enzyme is stored, right? Now as it is like a partly cooked meal, and when it is needed, it is opened and it is activated. Activated to enzyme and then this enzyme will take active role into the process of digestion. But till it is needed, it won't come out, right? It will remain there. So they come as needed. So obviously when we feel hungry, then and then we go to refrigerator, right? Otherwise we don't go refrigerator just for its darshan, right? We go only when it is needed, when we are hungry. So that is how this refrigerator, it works. We now move to vacuoles. Exactly. Storage vesicles, storage vacuoles, secretory granules, they all are same, right? It is also called as the secretory, right? So they all are one and the same thing. Storage vesicles, storage granules, secretory vesicles, secretory granules, secretory vacuoles, they all are same, right? Okay. On to our power banks, right? Mitochondria. Now it's almost over, right? Mitochondria. Just two points are left out. We know that this is powerhouse, right? This is powerhouse. So how exactly they work? Well, same principle, increase the surface area, right? How to increase the surface area? This is how it really looks like, right? That's the boundary of mitochondria, or it is a membrane. And when we say membrane, आँख बंद करके, this is bilayer and it is phospholipid. Phospholipid, right? That is the bilayer. So we are just drawing it like this. The inner one, right? This inner one, it is thrown into folds like this, this, and then this. It goes like this. This. Mitochondria looks like this. You need to know few names. One, this one, right? Those folds which are going on, which increases the surface area, they are called as cristae. Right? This inner one over here, right? This one, that is filled with something. What could it be? Well, for endoplasmic reticulum, we said endoplasmic matrix, right? So why to go for any new name? So this is also what is called as the mitochondrial matrix. So that's the matrix, correct? It is in this matrix where there is very interesting thing, and that is what is called as the oxidative phosphorylation enzyme. So it is called as the oxidative, right? Now the name is bigger, otherwise it is very simple. Oxidative phosphorylation enzyme, that enzyme is there. So what it is trying to do? Well, nothing. It will just do a process what is called as the oxidation. It will go for the oxidation of nutrients, right? Oxidation of nutrients. What would be the outcome? Outcome as expected, very simple. It will lead to formation of carbon dioxide plus water plus energy in the form of ATP. That's beautiful. That's what we really want, right? That's what we get. So this is how it is working. Now say regular exercise, right? Regular exercise would actually increase the number, increase the size of mitochondria. So that's where every cell will be generating more power, and that's what is needed, right? Say for example, cardiac muscles. Naturally, if you see, so cardiac muscles, they never tire. They constantly need energy. So cardiac muscles will be having much more mitochondria as compared to those adipocytes or the fat cells, adipocytes, right? Right? Make sense? Right? So this is its speciality, that it increases it multiplies, it is self-replication, right? Self-replication. And self-replication is possible because it has got the DNA. It has got the DNA. Right? So that's the DNA which controls that how much it should replicate, right? So it controls replication. It controls replication. So that's about the mitochondria. Moving on to the last part, and that is what we said about the cell cytoskeleton. Cytoskeleton, right? In case of cytoskeleton, only one part, one word, that is fibrillar protein, right? We have already talked about it. Fibrillar protein. Sorry. This fibrillar protein, fibrillar means it is like fiber, right? It is like fiber. So thin fiber, thin filaments, and these filaments, they are making what's called as the tubes, right? Tubes. So we have various types. One, what is called as the ectoplasm, which is on the outer side, right? Ectoplasm is having actin microfilament. Now, actin microfilament. Immediately, you will be able to understand these actin. They are tough or delicate, right? Because myosin, they were tough. So these are the actin filament which are delicate. Is myosin here? No, we don't want that contraction relaxation. This is just for support, right? They are thin. That's right. They are thin. They are beautiful, right? So they are for the support. But because there are so many, right? So that's why the whole meshwork is there. Then there are some intermediate filament. This is worth remembering. Intermediate filament. When we say intermediate filament, it is not on the basis of that their location. No. Actin is thin, myosin is thick, so this is in between. It is neither thick nor thin, so that's why it is called as the intermediate. There is no contraction. Its function is just mechanical. It is only a mechanical support, right? So such type of fibers, yes, such type of fibers, they are inside the cell because cell is not empty, right? So all those, as if it is like those inner walls, right? Those inner walls, that's how they are there. So when in the muscle cell, right? In muscle cell, and in fact, we have watched it, right? In muscle cell, it is called as the desmin, right? It is called as desmin, which is only for support because our working was that molecular motor was dynein, right? So this is in the neuron when it comes to nerves, right? So it is called as neurofilament. Again, simple. All of them, they are just for support. They won't be doing any other function, right? Epithelial cells, right? Skin, epithelial cells. So in epithelial cells, they are called as keratin, and we say that keratin is like a dead tissue. Exactly, it is like a dead tissue because its function is support. So their function is just support. Now, you remember we drew it something like this. Say this, there was this, and then this was like this, right? This, right? And we said that these are our molecular motor, right? And that molecular motor is dynein, right? Yeah, cilia, exactly, something which is moving, right? If we really draw all of them, right? All of them. So what we are watching, all these, they are nothing but they are our tubulin proteins, which are meant for support, right? Which are meant for support, and they are stiff. Oh, DDLJ, right? And these are all stiff filament because their function is support, correct? And this takes us to the final, our command center, and that is our nucleus. Nucleus is though doing so many things, but it is pretty simple. Nucleus, all you have to remember is that One first point, draw its membrane like this. Don't draw the membrane like goal chakkar. No, draw it like this, because nucleus has got nuclear membrane. Very right, it has got nuclear membrane, but nuclear membrane has got big pores. These are big pores, and through these big pores, yes, right, large molecular substances, they can also pass. And that's why this nuclear membrane is also called as the nuclear envelope. Nuclear envelope, right? Nuclear envelope. So this is one point, the pores. The second thing is that this nuclear substance, it is in continuation with, endoplasmic reticulum. Endoplasmic reticulum. It is in its wall is in continuation with endoplasmic reticulum. Its inner portion, inner thing, this inner one, right? Inner environment, that is continuous with endoplasmic reticulum, rough endoplasmic reticulum. That's right, right? So this is the second point which you have to remember. And when we say about the nucleolus, so what it is, this nucleus is doing, nucleus is giving the command, right? Because it has got DNA. Nucleus is giving command, grow, develop, right, or say die. All these commands, they go from nucleus, right? It simply handles this entire part. The nucleolus, it has got no limiting boundary, right? It has got no limiting boundary. And when there is no limiting boundary, so basically what exactly it is, nucleolus is very, all those files kept safely. It is simple accumulation of, right? It is accumulation of RNA, ribonucleic acid, plus protein. When it will be used? Well, as needed, right? Very similar to ribosomes. Right? That is what is there into the nucleolus. Now, because this nucleolus is vital, right? It is vital for synthesis of these proteins. So that's why whenever there is more protein synthesis, right, it increases in size. Right? So in nutshell, that nucleus, right, that nucleus, not nucleolus, right, nucleus which is having DNA, and this DNA, it tells that, okay, synthesize, right, synthesize RNA. And once this RNA synthesize, it will say that, okay, you remain there into the form of nucleoli, right? Rest of the DNA, right, it can go out, and then there are several functions which it will can handle. That's another part, right? So that's it. So this is the story of our beautiful cell, right? So do let me know if there is any query. Send a mail, right? Nucleoplasm, well, nucleoplasm is where that substance is, right? That's where the substance which is having DNA, and where it is going for all those protein synthesis, right? That's the environment in which the protein synthesis occurs. So thank you so much. It was a pleasure talking to you, and we meet tomorrow same time, right, with another topic. Thank you so much, and see you tomorrow. Bye bye. And I'm saving this file saved, and I'll be putting it into our share folder, right? So you can download it. Thank you and take care. Bye bye.